Hey, we're live streaming. We'll start at 8 o'clock. Alexander. Richard Reynolds. It will take me a few months to learn your names. I remember you for some reason. Michaela Shook. Mariana Butler. Okay. Kayla Williams. Gerardo Silva. Scott Fulton. Bo Hackworth. Jose Fabella. Austin Cook. Okay. Marcos Lopez. How much time do I have? Damon Kwando. Alexander Perez. Jose Favilla. Marcos Lopez. Joseph Vaughn. Yep, that's you. Gerardo Silva. Is that you?
Yeah.
Okay. Okay, I have everyone that's here. Yeah, we still have a little over a minute before it's time to start. So if you're online, go ahead and sign in. Hey, the computer clock says 8 o'clock. Today we'll discuss we'll learn how to solve other compound inequalities. Yesterday we discussed compound inequalities involving the word and. Today, we'll look at compound inequalities that involve the word or instead. So starting from the top, compound inequalities made up of two inequalities connected by the word or will be covered. So here's an example. Quote, either I will accept an offer to work at Google at an annual salary over $100,000, or I will accept an offer to work at Facebook at an annual salary under $90,000. Okay, so if we assign a variable like X to be the annual salary for this person, so the person is deciding between one of two jobs. So his salary will either be over $100,000, I'll just write X is greater than 100,000, or the other job, the salary will be under 90,000. So, or X is less than 90,000. Okay, one or the other. But all of the possible salaries exclude the amount between 90,000 and 100,000, right? Because it's either going to be greater than 100,000 or less than 90,000. So if you were to draw a graph of that, and we want to list all of the possibilities, well, it's 100,000 is to the right of 90,000. So if X is greater than 100,000, then it's to the right of 100,000. The other possibility is that X is less than 90,000, so that would be to the left of 90,000. And so in this next sentence, if two inequalities are connected by the word or, then numbers that satisfy either condition are included. So all of the numbers greater than 100,000 are combined with all of the numbers less than 90,000. Okay, the next sentence, two inequalities connected by the word or means that the union of the two inequalities consists of all numbers that satisfy either of the conditions. Okay, so the word union implies that we're combining both sets of numbers. And with interval notation, the symbol, the union symbol, it looks like a U. It's not really a U. It looks like a U, but it's a union symbol that's used just for convenience. We use that for the union. Okay, so I'll write down the algebraic notation and the interval notation for this inequality that we already wrote. Well, this first compound inequality, this is the algebraic notation. We actually use the word or. So I'll label it algebraic notation. Okay, the algebraic notation, we can write those in either order, but it might be easier to write X is less than 90,000 on the left and then write or. x is greater than 100,000. Then the interval notation, we're going to use the union symbol. Okay, so remember what the interval notation is for x less than 90,000? Okay, so in our interval notation, we're sort of departing from reality because we're going to write parenthesis negative infinity, comma, 90,000. We know that the salary can't go to negative infinity, but we're just thinking of this mathematically. So the interval notation for x less than 90,000 is parenthesis negative infinity, comma, 90,000. And then in place of the word or, we use the union symbol. And then x greater than 100,000, we put parenthesis 100,000, comma, infinity. Okay, so compound inequalities that involve the word or will involve the union symbol when we're writing interval notation, and we use the word or when writing algebraic notation. Okay, let's look at another example. This one's just a variation of the previous one. Google will pay me at least $100,000. So it's not simply greater than $100,000. It could be $100,000 also itself. Or Facebook will pay me no more than 90,000. Okay, so the algebraic notation, if I get at least 100,000 from Google, then I can write x is greater than or equal to 100,000. Or the other possibility is that I will get paid no more than 90,000. So, or x is less than or equal to 90,000. Okay, so the wording determines whether you include the or equal to part or not. So always read those carefully. Okay, that's the algebraic notation. The interval notation. So we can write the interval notation bracket 100,000, comma, infinity, union, parenthesis, negative infinity, comma, 90,000. This is perfectly fine. This is okay. But if you would rather write this as parenthesis, negative infinity, comma, 90,000, bracket, union symbol, and then bracket 100,000, comma, infinity, you might find the second one is more convenient because we normally read from left to right, and on the number line, the smaller numbers are to the left, the larger numbers are to the right. But either is fine in this case. Okay, we'll move on to the next page then. Okay, so here's a note. A compound inequality made up of two inequalities connected by the word or may include all real numbers. So the following example illustrates that remark. Okay, a solution to one problem is a number greater than 5 or a number less than 10. So if we write down the algebraic notation, why don't we use a different letter? I'll pick Y to represent the solution that's referred to. Okay, so a solution Y to one problem is a number greater than 5. So Y could be greater than 5, or the number Y could be less than 10. Y is less than 10. Remember, when the word or is used, we're going to write the union of all of the numbers. We're going to combine all of the numbers. So graphically, so if we look at two graphs, one where x is 5, or y is 5, I mean. So if y is greater than 5, it's all of the numbers to the right of 5. And if y is less than 10, it's all of the numbers to the left of 10. So all of the numbers included are all real numbers. You see that? So the union is all real numbers when we combine both sets of numbers together. Do you see that? So in this case, the union is all real numbers. We can write the interval notation. If y is greater than 5, then we can write parenthesis 5 comma infinity. This is numbers greater than 5. And then the union symbol, numbers less than 10 are from negative infinity up to 10. Okay, so this is technically correct, but it can be simplified because all real numbers are in that set. So the notation, the interval notation for all real numbers is parenthesis negative infinity comma infinity parenthesis. So we would want to write this as parenthesis negative infinity comma infinity parenthesis for all real numbers. Okay, let's look at some compound inequalities involving the word or. Write the following compound inequalities using algebraic notation and interval notation for these. These are basic examples. So understanding the basic examples is a preliminary requirement to understanding the more complicated ones. Hey, x is less than 3 or x is greater than 5. This is the algebraic notation. because in both inequalities, x is already by itself. So the interval notation, if x is less than 3, we write parenthesis negative infinity, comma 3. Since we're using the word or, that implies union. And then x greater than 5 is parenthesis 5, comma infinity. I guess it doesn't hurt to sketch a graph of this. So the finite numbers are 3 and 5. So this set of numbers from negative infinity to 3, excluding 3, we put a parenthesis that opens to the left. Then we shade to the left. This is from negative infinity to 3. And then union greater than 5. So from to the right of 5, but excluding 5. So you can see that the graph resembles the interval notation, sort of. Here, the next example is not much more complicated. This one is x is less than or equal to negative 4, or x is greater than 6. So this is already the algebraic notation. Then we can convert it to interval notation. If x is less than or equal to negative 4, we write parenthesis negative infinity, comma negative 4 bracket. The bracket indicates, that's what goes with the or equal to part. We're using the word or, so we have a union symbol, and then x greater than 6, parenthesis 6, comma infinity. So that is the interval notation. And let's go ahead and graph it. So the numbers negative 4 and 6. Negative 4 is to the left of 6. So if x is less than or equal to negative 4, we have a bracket at negative 4 and everything to the left. If x is greater than 6, we have a parenthesis at 6 and that opens to the right, and then we shade to the right. Yes, so just note the numbers that are not in the set. For this one, x is less than or equal to negative 4, or x is greater than 6. The numbers between negative 4 and 6 are not in that set. Okay, so sometimes it's useful to know not only what is in the set, but what is not in the set. Okay, another basic example. So now it's starting to get monotonous, but it's okay. X is less than 0, or x is greater than or equal to 10. So we can write down the interval notation. If x is less than 0, that's parenthesis negative infinity, comma 0, parenthesis. The word or is used, so we use the union symbol. And if x is greater than or equal to 10, we use bracket 10, comma infinity, parenthesis. I've mentioned this a couple of times, but I'll just remind you, when we're writing the interval notation, well, for a single set of numbers, we want the smaller number to the left and the larger number to the right. So negative infinity is to the left of 0. over here on the right, from 10 to infinity, 10 is to the left of infinity. So with interval notation, it has to be written a certain way. The algebraic notation, you have options. So we've seen that before. Just as an example, if x is less than 0, that is equivalent to saying 0 is greater than x. So with algebraic notation, we can write it in different ways. But interval notation, we have to always write it the same way. So smaller numbers on the left, larger numbers on the right. Okay, but that's for individual sets. So this is equivalent to writing, I can put those two sets in different orders. I could write bracket 10 infinity union, and then parenthesis negative infinity, comma 0 parenthesis. This is okay also. But in the individual set, the smaller number is to the left, the larger number is to the right. You see what I mean? Okay, a few more basic examples. So we can probably pick up the pace a little bit. Okay, x is less than or equal to -5, or x is greater than or equal to, did I say that right? X is less than or equal to -5, or x is greater than or equal to 7. So work on that for a second. I'll continue taking attendance online. I have a few more that signed in. Hey, no doubt you're already finished. This is already the algebraic notation. So we can write the interval notation. If x is less than or equal to -5, then we write parenthesis negative infinity, comma -5 bracket. The word or is used, so we use the union symbol. And then x greater than or equal to 7, we have bracket 7, comma infinity. Now let's sketch a graph. Plot the numbers -5 and 7. So this set of numbers from negative infinity up to -5, including -5, we put a bracket that opens to the left at -5, and we shade to the left. And for this set of numbers, greater than 7 and including 7, we put a bracket at 7 opening to the right and shade to the right. Okay, so the union combines all of the numbers into a set.
Except for what's between -5 and 7. Right?
What's that?
Except for what's between -5 and 7. That's not just 7.
What do you say?
Except what's in between, like -5 and 7, that's like excluded.
-5.
Yeah, what's in
What
between that?
negative-
Oh, in between, yeah, just the numbers between are excluded, is that what you're asking?
Yeah.
Yeah, the part that doesn't correspond to red, those are excluded. Yeah. Any other questions? So if you're online and didn't hear it, it was just asked, referring to the numbers that are excluded or that are not in the set. They're just strictly the numbers between -5 and 7. But the numbers -5 and 7 are part of the union. Okay, the next one, x is greater than or equal to 2, or x is greater than or equal to 4. Well, let's sketch this. So I'll plot the numbers 2 and 4. If x is greater than or equal to 2, then we put a bracket at 2 that opens to the right and shade to the right. And if x is greater than or equal to 4, I put a bracket at 4 and shade to the right. So what's the union of the two sets? We can write the interval notation, x greater than or equal to 2 in interval notation. This is bracket 2 comma infinity. The word or is used, so we use the union symbol. And then x greater than or equal to 4, we have a bracket 4 comma infinity. But we can write this more compactly. It's not that this is incorrect, we can just simplify it. So we're including all of the numbers that are in both sets. So what's the union? Note that the numbers from 4 to infinity are already in the other set. They're already in the set from 2 to infinity. Do you see that? So the union then is just bracket 2 comma infinity. So this is the one that we want, the simplified interval notation. The graph can help if you just remember that the word or means we're combining all of the numbers in both sets. It's just that, well, some of the numbers are represented more than once, but that's okay. When we write the single set, then each number is in the set once. Any questions on that part? Okay, so the algebraic notation can also be simplified. And the interval notation might help us. So these numbers are just the numbers that are in this set from 2 to infinity, including 2, are numbers that are greater than or equal to 2. So we can write x is greater than or equal to 2 to represent that set using the algebraic notation. And once again, the reason is the numbers x that are greater than or equal to 4 are already numbers that are greater than 2. So they're already in that set. Okay, the next one, x is less than 1 or x is less than 8. So what's going to happen this time? Hey, it's okay to draw a graph. That helps. So let's plot the numbers 1 and 8. So x is less than 1. Those are to the left of 1 on the number line, or x is less than 8. So those are the numbers to the left of 8 on the number line. The word or is used, so we're going to include all of the numbers that are in both sets. So the numbers that are less than 1 are also numbers that are less than 8. So this algebraic notation can be simplified. We can just say x is less than 8. Okay, then the interval notation, well, we know what the interval notation is for x less than 8. But if you start at ground 0, x is less than 1, that's negative infinity to 1, parenthesis, and then the word or is used, so we use the union symbol, and then x is less than 8, that's negative infinity to 8. But this can be simplified to the set of numbers from negative infinity to 8, parenthesis. So this is the simplified interval notation that we want in this case. Is this making sense? Okay, another one, x is greater than or equal to 3, or x is less than 5. Okay, let's plot the numbers 3 and 5. First of all, x is greater than or equal to 3. We have a bracket at 3 and we shade to the right. So this is from 3 to infinity, including 3. X is less than 5, parenthesis at 5 and shade to the left. So a number is either x greater than or equal to 3 or x is less than 5. Since we're using or, we're combining all of the possibilities. So you can see the entire number line is the solution set. So all real numbers are solutions. So in this case, we just indicate all real numbers. The interval notation for all real numbers is parenthesis negative infinity, comma, infinity. Okay, we'll do a few examples that are a little more involved. But once we get x, or whatever the variable is, all by itself in each of the inequalities, then we'll just apply what we did in the basic examples. Okay, solve the following compound inequalities, write the solutions in algebraic and interval notations. So in this one, we have x over 4 plus 4 is less than or equal to 3, or negative x plus 2 is less than or equal to 2. So we want to solve each of those inequalities individually for x, and then we'll deal with it the same way we did in the basic examples. So this one, x over 4, x divided by 4 plus 4 is less than or equal to 3. Step 1, we subtract 4 from both sides. So we get x divided by 4 is less than or equal to -1. And then we use the word or. The inequality on the right, -x plus 2 is less than or equal to 2. So subtract 2, we get -x is less than or equal to 0. Here, 0 is a perfectly fine number. Okay, now x over 4 is less than or equal to -1. So to solve for x, we can multiply both sides by 4. So I'll write a little bit of detail. Multiply both sides by 4, or 4 over 1, less than or equal to 4 times -1. And then 4 over 1 times x over 4, the 4's canceled, so we just get x is less than or equal to -4. Then we're using the word or, so we're just one step away from solving this inequality for x. If -x is less than or equal to 0, if we divide both sides by -1, we can write x on the left. Since we're dividing both sides by -1, we have to switch this inequality to greater than or equal. And 0 divided by -1 is still 0. Okay, so this is the algebraic notation. So this is the algebraic notation. Let's go ahead and graph the solution set. X less than or equal to -4. X greater than or equal to 0. So x less than or equal to -4, we have a bracket at -4 and shade to the left. X greater than or equal to 0, we have a bracket at 0 and shade to the right. Okay, so we can use the graph or the algebraic notation to write down the interval notation. So in my mind, the graph is more explanatory when it comes to writing the interval notation. This part of the number line on the left, this is from -infinity to -4 bracket. And then we're using the union symbol because the compound inequality has the word or. And then this part of the number line, from 0 to infinity, including 0, bracket 0, comma, infinity. Okay, so this is the interval notation for the solution. Okay, a couple of more examples. The next one, x plus 6 is greater than or equal to 3, or -4 plus 3 is greater than -1. Okay, on the left, we'll start by subtracting 6 from both sides, and we'll get x is greater than or equal to -3. Then we use the word or. This one, -4x plus 3 is greater than -1. Subtract 3 from both sides. We get -4x is greater than -4. X greater than or equal to -3, this is already solved, well, for that part. And then one more step for this inequality on the right. If -4x is greater than -4, we divide both sides by -4, and we write x is less than +1. Okay, let's graph those inequalities. The numbers -3 and 1. -3 is to the left of 1 on the number line. Okay, so if x is greater than or equal to -3, we put a bracket at -3 and shade everything to the right all the way to positive infinity. And if x is less than 1, put a parenthesis at 1 and shade to the left. Okay, so what's the union? We can convert this to interval notation. X greater than or equal to -3. This is bracket -3 comma infinity. The word or is used, so the union or the combining of the two sets. And then x is less than 1, parenthesis, -infinity, comma 1. But in our graph, we see that all real numbers are represented. So the interval notation that we want in this case is for all real numbers. So it's parenthesis, -infinity, comma infinity. So all real numbers are solutions. Okay, one more example. X divided by 5 plus 2 is less than or equal to 3, or -x plus 14 is greater than or equal to 6. Okay, so for the one on the left, we begin by subtracting 2 from both sides. So we get x divided by 5 is less than or equal to 1. And then or on the right-hand side, we'll subtract 14 from both sides. So we get -x is greater than or equal to -8. For the inequality on the left, x divided by 5 is less than or equal to 1. How do we solve this for x? We can multiply both sides by 5. I'll write that in a little bit of detail. Multiply both sides by 5. 5 over 1 times x over 5 is less than or equal to 5 times 1. And 5 divided by 5 is 1, so the left-hand side simplifies to x, and that's less than or equal to 5. And then -x is greater than or equal to -8. We can divide both sides by -1. In this case, we can multiply both sides by -1. Either way, we're going to get x is less than or equal to +8. Okay, so x is less than or equal to 5, or x is less than or equal to 8. The interval notation, if x is less than or equal to 5, it's parenthesis, -infinity, comma 5 bracket. We use the union symbol for the word or. X is less than or equal to 8, that's parenthesis, -infinity, comma 8 bracket. So are we done? Do we have the most simplified algebraic notation and the most simplified interval notation? No, we can simplify further. If we just take a look at the graph, plot the numbers 5 and 8. Hey, if x is less than or equal to 5, that's put a bracket at 5 and shade to the left. If x is less than or equal to 8, we put a bracket at 8 and shade to the left. So the union of the two sets, the combination of all of the numbers in both sets, for algebraic notation, it's x is less than or equal to 8. So this is the algebraic notation that we want. And the interval notation is from negative infinity to 8 bracket. Okay, so once again, it's not that these are incorrect, it's just that they can and should be simplified further. Hey, those are all of the notes that I wanted to get through today for class tomorrow and also on Thursday. We'll be in chapter 2, section 7 on absolute value inequalities, absolute value equations, and absolute value inequalities. And so we will use a lot of the things that we discussed yesterday and today when we solve for absolute value equations and inequalities. Okay, but that's all for today.